model-based reflect agent. So here in the previous case, the simple reflect agent will be working properly only if the environment is fully observable. If the environment is not fully observable, means that if it is partially observable, then it means that some part of the environment cannot be seen properly. Okay, so it will not get complete information to take the action. So in that case, the model-based reflect agents will be performing well. So, for example, if you take here, to avoid this unobserved, partially observable environment, what it has to do, it should have some internal state. The agent should maintain some internal state. Okay, the internal state depends upon the percept history. Okay, so that if there is anything is not observable from the environment, using this internal state, the state of the environment will be updated. Okay, so that is the importance of model-based reflect agent. So, for example, the braking problem just now we have discussed. No? So, whenever there is a car in front brakes, what happens? The lights, brake lights comes on. Okay. So, if the brake lights is not observed properly, what happens? The agent will not put the brakes. Okay. He will not apply the brake so that there is a serious problem. To avoid the serious problem, what it has to do? It has to take the previous sequence, that is the previous frame as the it has to refer and it has to check whether the brake light is on or off in that previous frame. If the brake lights are on, then what it will do, it just apply the brakes. Okay. And for example, in the driving task like driving tasks such as changing the lane. Okay, here what is that? The agent should always keep track about other cars. Okay, if it is it's because the other cars cannot be seen properly or all at once. Okay, so that is why that is one more problem. In that case also, the it should have the internal state to get the updated information. So, to get the internal state, the agent should have two types of knowledge. What are the two types of knowledge here? How the world, first knowledge is that how the world evolves independent of agent. Okay, without agent action, how the world is. Okay, the present state of the world, it should not. Okay. For example, in the overtaking cars, so here agent is just going in some speed. So the other cars are overtaking this car. Okay. So maybe see if this car has to overtake the agent car, what it will do? For after some time it will move near to this yes or no? This should be observed properly. So here, what is that happening? There is no change in the agent, only the change in the environment. Okay. So that the how the environment is changing without agent action, that should be known. Second one is so, for example, if agent is turning his steering wheel clockwise, what happens? The car will move towards right direction, towards right side. Okay. So for 5 minutes of drive, what happens? It might have reached 5 miles from the point where it has started. Okay. Means that the environment is changing from one. So I am at one location. Now, since the vehicle steering vehicle turned towards clockwise, so it is moved from this location to another location, maybe 5 kilometers away from this. Yes or no? So environment is changing its location. Okay. So like that, with the agent action itself, the environment is changing. So these two information should be known. So this knowledge gives, that is two types of knowledge we want. That is how agent will be without, how the environment will be without agent action, how the environment will be with agent action. These are the two types of knowledge the agent should have. Okay. So this knowledge about how the world is working is called model of the world. What is the model of the world? So the knowledge of the world, how the world works, that is with the agent action, without agent action, how the world is working. That is called model of the world. So the agent uses such a model is called model-based agent. So agent which is having this type of model, this type of knowledge is called model-based agent. So the figure here shows the model-based reflect agent. You see here, this will be, see here, we are getting updated state here. So what it takes, it will take the current percept, okay, and it is also having the percept history. The previous state of the environment is also stored here. See here the current state and the previous state is also stored here. Combining with the current state and previous state, we will be getting updated state of the environment, okay, and it is also having two types of knowledge, that is how the world evolves, and the second knowledge it is having what agents' actions can change the world, how the world is changing with the agent action. Okay, so these two information it will be loaded here, so that we'll get complete information about the environment. So this is called model of the environment. What is this called model of the environment? This have the updated state, as well as we will have the information about how the world without agent action, and it will have the information about how the world with the action, with the agent action. Okay. This the information through together is called model of the environment, and this will be given as the input, and from this action condition action rules, will be selecting a rule that matches this condition properly. That action is given as the action to the actuators. That action will be performed on environment. Okay. So this is a simple model-based reflect agent. So here, this is the complete part that gives us the model of the environment. So this is the part similar to the simple reflect agent. The program of this is given like this. So it will take percept as the input and gives an action as the output. So just now we have discussed that we'll be updating the state of the environment by using the database called state. Okay. So then we have condition action rules. So the condition action rules will be stored in the database called rules, and this condition action rules will give the actions. Submit. So what are the actions here? These actions depend upon the condition action rules and state of the environment. And what is that? We have discussed that the state of the environment will be updated here every time. So what are the information that is required here? It gives the state of the environment and what is the action that the agent is taking, so that how the environment is changing, and the what is the current percent. These are the three things required for this update and the school state, and it gives us the current state of the environment. Okay. And what is this rule match? These two are similar to simple reflect agent. This we have already discussed. So what is rule match? Rule underscore match will take state as the input and rules, state and the rules as the input. It will give the first rule that matches that state and rule properly. Okay. So that rule as the given to rule underscore action function that gives the action. That action will be returned. So this is a model-based reflect agent. It keeps the track of current state of the world and it chooses an action